All right, here are your notes on graphing lines. The first thing I want to make sure that you know is what a linear function is. So linear, it's got the word line in it. That means you are a straight line. A linear function, that's like an equation. So it is the equation for a straight line. When you graph it, so linear functions are going to have an x value and a y value. The graph is a straight line. All right, so that's what we're going to be getting into, linear functions, graphing straight lines, equations for the graphs. So if you are nonlinear, and we will be getting into nonlinear functions later in the year, you are not a straight line. So let's talk about what a linear function or the equation for a linear function looks like. All right, so let's talk about a linear equation. All right, here's an example of a linear equation. Now, when you graph a line, you have an x-axis and a y-axis, so that means you need to have an x value and a y value in your equation. So we will use the variables x and y. Here's an example of a linear equation. All right, y equals 2x plus 4. If I were to give you a value for x, you could plug that in and you could tell me the y that it goes with. For example, if I wanted x to be a 0, there is a particular y that would go with that. So if x is a 0, you'd have 2 times 0, which would get rid of this. You'd have a 0, and 0 plus 4 would leave you with a 4. So if I plug 0 in for x, the y that goes with it would be a 4. So you're finding pairs of numbers that go with each other in a certain equation. And that's called an ordered pair. All right, so if you have an ordered pair, you have an x value paired up with a particular y value. And that's how you would show an ordered pair, with parentheses. So an ordered pair shows a solution to a function or to a linear equation. All right, but think about it. If I plugged a 0 in for x, 4 was the only thing y could be. Y could not be anything else. So we only had one value that could go with the x that was plugged in, one y value. So an ordered pair is considered to be a solution. Now, I could plug anything I want to in for x, so you can have a lot of solutions, a lot of ordered pairs that would work. If I plug a 1 in for the x, because I can make x anything I want it to be, 2 times 1 would be 2, 2 plus 4 would be 6. So if I plug a 1 in, I get a 6 for my y value, so 1, 6 would be a solution. And I could go on forever finding solutions. And that's what brings us to showing what all of the solutions are. You can't list them all because it would be endless. So a lot of times you graph all of the solutions on a coordinate plane. All right, this is your y-axis. Your y-axis is always up and down. This is your x-axis. That is always your horizontal. You have 4 sections, and these 4 sections are called quadrants. Okay, 1 is the upper right. And then you go counterclockwise to get to quadrant 2. So this would be quadrant 2, and we'll use Roman numerals. Then keep on going in that direction. This would be quadrant 3, and this would be quadrant 4. Now I want you to think of these as number lines, horizontal number line and a vertical number line. So this would be your 0 for both number lines. They call that the origin, where x is 0 and y is 0. There is your origin. So if this is 0, going to the right on the x-axis, those are your positive values, and going to the left, those are your negative values. For the vertical number line, the y-axis, going up from 0 would be your positive values, and going down from 0 would be your negative values. So if you wanted to go into quadrant 1 and you wanted to find any ordered pair in quadrant 1, you always start at your origin. You would go to the right, so that's a positive value for whatever number that is, it would be positive, and then up. Y is always your up or down. You'd have to go up to get to quadrant 1, and up is a positive value. So any ordered pair in this quadrant would be 2 positive numbers, like 2, 4, or 3, 8. All right, if you wanted to get to quadrant 2, starting at the origin, you wouldn't go right this time, you'd have to go left. X is always a sideways move, and that is the direction you go in first. So think alphabetical. You always put the X first. I'd have to go left. So that means any number that would be my X coordinate would have to be a negative value because I'm going left. And then from there, I'd have to go up, and again, that's a positive value. So all my X's are negative over here, and all the Y's are positive. So you'd have a negative paired with a positive for the ordered pair if you find it in this quadrant. For quadrant 3, from the origin, again you would go left for your sideways X value. Left again is negative, but this time, once you go left, if you go up, you get to quadrant 2. You need to go down to get to quadrant 3. Down is a negative value. All of your ordered pairs have both values negative in quadrant 3. In quadrant 4, we'll put that down here. From the origin, you go to the right, sideways first, and that's your X value. Going to the right, those are all your positive numbers. So once you go to the right, you have to decide, do I go up or down to land in quadrant 4? And I would have to go down. Down is a negative value. Any negative number would take you then down from that point. So all of your ordered pairs would be a positive number followed by a negative in that quadrant. So let's talk more about solutions to an equation. We're going to try an example. Before we get to seeing if an ordered pair is a solution, I want to show you probably the easiest way it is to use an equation and see if you can arrange the values. Let's say I give you this equation. You need an x and a y, and so I'm giving that to you. And I want you to solve this equation for y. So this is very similar to a lesson we just had on literal equations, where you need to rearrange and manipulate the problem so you can get the variable that you want all by itself. When you have the y alone, it's much easier to use the equation to see what ordered pairs would be a solution for it. All right, here's our y. So this is what we are going to leave alone right now. We need to move the x over, and we need to move the 6 over. We can only have this over here. We'll eventually then get rid of the 3. Okay, so I'm going to go ahead and move my x over. If I'm subtracting x, I then add x. So now that makes the x's disappear. You have 3y. You still have your minus 6, and now you have the 0 plus x, which is simply x. Now the 6 needs to go over. They're subtracting 6. We will go ahead and add 6. 6's cancel. You are left with the 3y. These can't go together, so keep them separate over here. You had the x, now you add 6. So we've done this before. We now just have the 3 to get rid of. The 3 is being multiplied. So the opposite of multiplying by 3, divide by 3. And this is where I would like you to start getting in the habit, instead of dividing the entire thing by 3, let's go ahead and divide each one individually by 3. That's what we'll start doing now. Let's clean this up. The 3's cross cancel and you get a 1y. Think of this as 1 over 3, so you can keep that as x over 3, or you can write that as 1/3 x. Either way is fine. For now, we can keep it x over 3. That means whatever your x value is, you divide it by 3. And let's simplify this. 6 divided by 3 would be a 2. Our y is now alone. All right, so now we've gotten our equation with the y alone. I could at this point easily plug in different x values that I want and do simple math over here and see what y would go with it. So this is a good way to have your equations. Let's do a different example. I'm going to give you an ordered pair. Remember, this is your x value, this is your y value. And I want to know if that ordered pair, if that's a solution to this following equation. Now, I'm going to write this equation in a different form. I'm not going to have the y alone because I want you to know how to use it when it's in any form. Okay. Now we could, if we wanted to, get the y alone, or we can work with it this way. So if we choose to leave it this way, let's see how that happens. All right, your y is an 8. That's going to go right there. Your x is a -3, so that will go right there. So what you can do is plug both values in and see if this side ends up coming out to be 0. If it does, then this ordered pair works. If your values work when you plug them in, then it is a solution to the equation. So let's go ahead and plug in. Y is an 8. There's your x value, and x is a -3. If that does equal 0, then this is a good ordered pair. 16, this will be -9. -6 equals 0. So we've got 16 minus 9, which would be a 7. 7 minus 6 is not going to equal a 0. So this ordered pair is not a solution. If our math had worked out and we did get a 0, 7 minus 6, or if we had a 1 over here, then that would have been a solution. So if you get the two sides to balance out, you're good with that ordered pair. This one did not balance out. All right, we'll do one more. This is where you're going to need the piece of graph paper that you received because I want to actually graph. I would like to graph that equation. The easiest way to graph an equation is to get the y alone. So to do that, I want to leave the y there. I'm going to move the 2x to the other side. That's a positive 2x. I'm going to subtract 2x. So the 2x's cancel out. You're left with y equals. And what I'm actually going to do is put the variable term first. If I'm subtracting 2x, that tells me it's a -2x. So I'm going to write that first, and then that's a positive 1, so I'll put that at the end. That's just a very common form for an equation when you're graphing, having the y alone and then having your x term with your constant after it. So this is where I want to introduce to you a table. Okay, I'm going to make a 4-column chart, and this is what I want you to show when you do your assignment. Your first column will list your values for x. Now you actually get to choose any x values you want. You must have at least 3 x values. Okay, 3 minimum. Then in the biggest part of your chart where you show your work, you put down what the function rule is. To get your y value, you take your x, multiply by -2, then add 1. So I'm going to call that the function rule. It tells us what to do with our x value. When we do the math, that will be our y value, and then my 4th column, solution. I'm going to put the x with the y and create an ordered pair, and this will be the points that I graph on a coordinate plane. So you can keep your numbers very simple. I'm going to choose to do a negative value. 0 is always a good value. Let's start with a -1. Plug a -1 right here. So this is what you're going to follow. You're evaluating. You're going to plug a different value in for x each time, and you get to pick what that value is. So -2 times -1, and then add 1. That'll become a +2 plus 1. My y value is a 3. So I have found one solution so far. If x is a -1, y is a 3. I need 2 more values, and what I usually do is wherever I start, I go in order and create some kind of pattern with my x values. They call this the domain. I'm going to choose 0. Then I'll probably keep going up by 1. So now I take this same function rule, but put a 0 here for my x, so everything else is the same. -2 times my value, then add 1, and this time I want my value to be 0. -2 times 0 would get me 0, add 1, and I get a 1. Put your x value with your y, your input with your output. We plugged a 0 in, we got a 1 as our output. That creates a second ordered pair that we can graph. We're hoping that all these points we find will line up in a straight line. Let's go up by 1 again. If you have a pattern with your x's here, you're going to find some kind of pattern with your y's. All right, same function rule. Take your -2, multiply it by whatever x is, then add 1, and we want a +1 there. That'll get us a -2 plus 1, which is a -1. Yep, these are going down by 2. Ordered pair 1, -1. So if they're telling you to graph it, what they're actually wanting you to do is they want you to plot all the ordered pairs that will work. And remember, you can choose anything for x. So this chart would go on forever. I just need 3, but x could be anything. It is impossible to show every ordered pair that could be a solution. So in order to show what all the solutions are, you just pick a few of them to graph. So go ahead and create your xy axis, your coordinate plane, and let's make sure we know how to graph these points. You always start at the origin, and this is where you may want to pause anytime and then play it again when you're ready to go on. Always start at the origin. You can look at the signs and find out what quadrant they're going to be on if you refer to the notes earlier. This is your x. This is your y. X is always your sideways move. X is sideways, your y is your vertical move. You always move sideways first. So from the origin, that's a negative direction. I go left 1 box. So jump 1 box to the left and stay there. Don't put a point though, just stay there. This is your vertical move. It's positive. When you're talking vertical, positive is up. 3 boxes. 1 box, 2 box, 3 boxes. If you put a point, make sure there's 3 boxes below it. That is your first ordered pair that your line will go through. Let's try this one. Remember, this is your X, your sideways move. This is your Y. Always start at the origin. This says do not move sideways at all. There is no sideways move. You just go up one box, and that's where you put your point. Make sure you do both moves before you put your point. Now go back to the origin because we have our last point. See, any 2 points will create a line when we connect it. Our third point is to make sure that it also lines up with these. This is your X, this is your Y. This is your sideways move. It is positive. To go sideways, positive is to the right. So start at the origin and go one box to the right. Don't make any points yet because you still have your second move. Make a horizontal move, then a vertical move. This is your up or down movement. It is negative. Remember, up is positive, down is negative. So that says from here, go down one box. And now your point can go there. These 3 look like they line up. These are only 3 of the many solutions we have. So what we do is connect the 3 that we have. They all line up. And notice I'm filling in all the spaces in between. Those are also ordered pairs. Every point you see on this line is an ordered pair. That would be a solution. That's how we graph them all. You need an arrow, though, because solutions go forever in both directions. So there's your example on graphing lines, and we'll talk more about it when you guys get to class.